Welcome. In this video, I will show you design of a complex surface imported from AutoCAD to RoboStructural analysis for analysis and design. Now we are going to start by modeling our, our complex shape here in AutoCAD, and then we can then export it to Autodesk RoboStructural. So I will make sure that I'm in 3D modeling. I've just started a new drawing. Now make sure that in home you are in Southwest isometric. Then you can just type unit and then click units. Make sure you're in architectural and then precision. That okay, insertion scale, then just leave it at that, then okay, and then dim style. I'm going to change the dim style, modify. I'm going to change this one to, let's say 3. Text, I'm going to change to 3. And then primary unit, I'm going to change to architectural precision 0 feet 0 inch, and then okay, close. So I'm going to draw a circle of 30. So 30 feet, 30 feet, and then radius, enter. So that is a diameter of about 60. We can confirm by going to annotate, change this one from linear to diameter, click on the circle, and then you can insert. You can see that the diameter is 60 feet. Then I'll go to home, activate line, and then activate orthogonal. So then make sure you have nearest, intersection, endpoint, midpoint, and center. And then from that point, I want a height of about 10 feet. Enter. And then I'll just pick it, go to array. You can select polar array, the center of the circle. Then those are okay with me. Hit enter, and I can just move my UCS away. Now I want to draw one using line at the center in the Z direction. I want to type 20 feet, enter. Enter. Okay, now after that, I want to draw my arcs. So I'm going just to remove this circle because I'm done with it. I'm going to move this, just pick and then uncheck here. You can just move it to that endpoint. We can rotate or we can change so that we can change the XY plane from, if you click inside that center point, you can see it's currently in world. So we can rotate about X, and then check restrict cursor orthogonally. Okay, now right click, rotate about X. Now that is, I've changed my XY plane. I can just again select and then pick at the X direction and move it to this endpoint. So you can see the way we have changed our XY plane. Now I can just activate this one, the arc. I will use start end angle. So my start is there, my end is there, and can say Okay, let me uncheck from this direction. Because my arc, I want my arc. Okay, my arc is okay. That point, let's say 12 degrees. The 12 degrees is too small. We just increase the angle a bit from that endpoint, 30 degrees, enter. Okay, it seems that those are too small, so we can just increase it. To 45. I'm sure the angles are too small. Should we increase the angle to 90? Because I want the curve to be visible. Okay, start endpoint. It's too small. I don't want to waste much time here. There, and then include angle 90. Enter. I'm going to pick that and this bottom side. I'm going to move the x-axis from this end to that end, and just rotate it another arc from that point. So I want it to be the other way around. So this, that point, okay. We can just move it to that end, then pick the x, then move it to that end. Again, you can just repeat the process. Pick that point, and then that point. From there, you can just copy, pick, right click, copy selection from that point, pick, right click, copy selection from that point, then pick, right click, copy selection from that point to that point. Okay, now I'm going to move this one to that endpoint, and then I want to move this x to this point. Now we can draw another arc from that point. I want it to be the other way around. They have to face the opposite side, so we can start with the opposite side. Then let's say an angle of 180 is too much, 45. So that is working. Then just move the x-axis to that point. Again, repeat from that end. that end, then 45, enter. Move the X to that point, repeat from here to there, 45, enter. Move X to that endpoint, repeat from here to there, 45, enter. Press scroll plus shift to just rotate. I will move the X to this point. Then 45, enter. Okay, from there, that point, 45, enter. Now, my last step is to use the good surfaces, to use the loft tool. So make sure you have the surface, you have this one and a surface associative checked, and then you can just pick loft, pick that surface and that surface, and then enter. Pick guide, this guide. We're going to pick, okay, so let's just repeat that surface and that, enter, guide, then enter. Again loft, enter, hit enter and then guide, enter. I'm going to pick loft, enter, guide, enter. You can just pick them, right click, isolate, hide objects. Now we're going to go to loft, the remaining three, enter, guide, enter, loft, this one, that one, enter, guide, enter. You can just right click, repeat loft, that one and that, enter, guide, enter. And you can just right click, isolate and object isolation. Now we can go from, now first we can change the UCS by right clicking at the center, just move it, and just escape. Pick the UCS, pick that point, right click, then change to world, and then you can change from 2D wireframe to realistic, and you can clearly see our tent. Okay, after that we can pick all the surfaces, right click, select similar, go to mesh, click mesh, that option, that arrow at the bottom, and then I will pick triangular, change this one to 1 feet, 1 feet 8 inches, 40 degrees, maximum angle between 40 degrees, 1 inch, 1 feet 8 inches, and then click OK, and then click create mesh. Now we go to the wireframe. You can see our mesh. Now we can pick again, right click, select similar, and then we want to explode. Now before exploding, we can just go to home, click layers. We can add just new layer. The depth point layer is for dimension. If you add dimension, a new layer for depth points is automatically created. So I want to create a layer for surfaces and another layer for columns. Then I will change the colors to red. On column, I will change to blue. So you can just pick all this, then I will change the layer to columns. And then I'll pick the mesh, right click, select similar. I will change this one to surfaces. Then you can just click, select similar. We want to explode. Type in explode and hit enter. Now we can see what just happened. Okay, now just rotate. I will pick and then change to column. I will select everything, right click, quick select by layer, layer 0, and then I will delete. So I'm left with my surfaces and my columns only. And then we can just save as. I'll save in my desktop. Tent update. Close this one. Go to robot. Just click a new project. Then go to open. We need to open. Go to file. Open project. Change from robot RTD to DWG. Then the save location was in my desktop. So tent update. Open. Then okay. Okay. Go to geometry, columns, and just create a new property. Follow section, pipes. I want pipe of 3, then add. Yes. Just select all of these, go to section, change to pipe 3. We can go to geometry, panels, object list, just select, and then you can modify here. Because I want this is a tent, I want to assign a thickness of 0 inches because I don't want any self weight, and then close. I will change here to RC shell and model to shell, and then this will take some time because they are 1490 numbers. Just click add and wait a few minutes. Okay, we have generated shell. Now we need to go to edit, select, bars, undefined, move up, and then hit delete. The X, as you can see here, is going to delete all those bars. So the bars have been deleted. Now make sure we have support. Then apply, close. You can change display, panels, display panel thickness, apply. Remember my thickness is 0. Change, remove panel thickness, apply. I want to assign loads, so I'll go to wind load simulation. Okay, we're going to go to minus, positive y, and positive x, minus x, and The wind speed is 140, and wind profile is 1, and then start. Okay, wind load has been generated in both directions, and then we can go to loads, go to load type, can assign self weight in addition to this. So just add dead load, then close, and then we can now proceed to do our analysis. So just click calculate. So this one is going to remesh everything. It's going to take a lot of time. So let's uh, run our analysis. So you can just start calculation. So there is no panel thickness. So don't worry, because this one was done intentionally that I need to add a panel with zero thickness. So we did this very intentionally. The issue that is going to take a lot of time is remeshing these panels. So we can just wait. So that error we can ignore because this was intentional. So it's doing generation of a free mesh. Then it's going to start to check and fix the errors in mesh because this mesh was generated from AutoCAD. So it's deleting mesh inconsistencies. Just wait for the process. We have only two warning. We can ignore isolated node and the thickness. So yes, because we don't want the self weight of that shell. I think this issue of instability is due to zero thickness in my panel. We're going to check how to deal with that. And maybe because we have assigned wind load. So the wind load, this is how it brings the instability in the model. Because if we didn't have the wind load, then for sure we would not be having the warning. And there are so many nodes, up to up to 40,000 nodes. So I'm going to stop the video for here. We can continue in the next in part 2.